Nobody built Stonehenge by accident. That much has always been obvious. You do not drag 80-ton blocks of sandstone from 20 miles away, or carry 4-ton slabs of bluestone across 225 miles of Welsh hillside and open sea because the mood strikes you on a Wednesday afternoon. You do not align a circle of standing stones to the exact rising point of the midsummer sun, so precisely that it has held its alignment across 5,000 years of continental drift. I've heard of polar wobble, of the slow grinding shift of the Earth's axis, without a level of astronomical knowledge that most people in the 21st century do not personally possess. And you do not build in 3 distinct phases across 15 centuries, each phase refining and completing the work of the one before, without a plan that was conceived, remembered, and honored across generations of human beings who left no writing, no maps, no blueprints, and no explanation. Just the stone, just the circle, just the silence that has been sitting at the center of the Salisbury Plain since before the pharaohs began their first dynasty, before the first letter of the first alphabet was scratched into clay, before anything we recognize as civilization had left its mark on the world. Stonehenge has been studied continuously for over 400 years. It has been measured, photographed, drawn, mapped, cored, radar scanned, satellite imaged, and argued about by some of the finest archaeological minds in human history. Every theory that could be generated by human observation working at human scale has been generated, and still at the end of all that effort, the monument holds its silence on the questions that matter most. Who built it? Not in the narrow sense of which group of Neolithic Britons did the physical labor. That is understood broadly enough, but who conceived it? Who knew enough about the sky, enough about mathematics, enough about the long cycles of the moon and sun to plan something that precise? And why Salisbury Plain? Why that exact circle? Why those exact proportions? Why 56 holes in the outermost ring? Why 19 stones in the inner horseshoe? Why those numbers, repeated in those places, with that geometry? In 2026, those questions were fed into an artificial intelligence for the first time with the full weight of the accumulated dataset behind them. Not a selective dataset, not a curated set of observations shaped by a particular theoretical agenda. Everything. Every measurement ever taken, every survey, every ground-penetrating radar scan, every astronomical calculation, every analysis of the monument's geometry, its stone chemistry, its soil stratigraphy, its astronomical alignments. 3 centuries of scholarly attention compressed into a single analytical pass by a system with no preconceptions, no career to protect, no institutional framework to maintain, and no investment in any particular answer being correct. Taj, what Grok AI found when it ran that analysis was not what anyone had been looking for. And the reason it was not what anyone had been looking for is precisely because no single human scholar had ever been able to hold all of that data in their head simultaneously and see the pattern that runs through all of it. To understand what the AI found, you first need to understand what had already been known and why it was not enough. The basic astronomical alignment of Stonehenge has been understood in broad terms since the early 20th century. The monument's primary axis points toward the rising sun on the summer solstice and the setting sun on the winter solstice, creating a line of sight that frames these events with theatrical precision. On the morning of the longest day, standing inside the circle and looking northeast through the great trilithon archways toward the heel stone, you watch the sun climb exactly over that lone standing stone as if placed there deliberately. You are looking through a doorway built for this exact moment by hands that worked 5,000 years before yours. It is not subtle. It was not an accident. It was the most explicit, intentional astronomical alignment in prehistoric Europe, and its existence has never been seriously disputed. But the alignment of the axis to the solstice was only the beginning of what Stonehenge was doing astronomically, and it was the simpler part. In 1963, astronomer Gerald Hawkins published 2 papers in the journal Nature that reframed the entire discussion. Hawkins had fed Stonehenge's measurements into a computer, an IBM mainframe, one of the most powerful computational tools available at the time, and run a systematic analysis of which celestial events aligned with which features of the monument. What he found extended the picture far beyond the solstice axis. The monument was aligned not just to the summer solstice sunrise and winter solstice sunset. It was aligned to the rising and setting points of the moon at the extreme positions of its 19-year cycle. It was aligned to the equinox sunrises. It was aligned to a set of astronomical events so comprehensive that Hawkins concluded Stonehenge was functioning as a deliberate astronomical observatory, a machine for tracking the sky across multiple cycles simultaneously. The most explosive part of Hawkins' analysis concerned the 56 holes in the outermost ring. These pits, known as the Aubrey Holes, named after the 17th century antiquary John Aubrey, who first noticed them, are evenly spaced in a perfect circle around the monument. They predate the standing stones by several centuries, representing the first deliberate construction at the site. For decades, they had been treated as post holes or offering pits, their purpose unclear. Hawkins proposed something completely different. He suggested that the Aubrey holes were a counting device, a physical calculator for tracking the 56-year cycle that emerges from the relationship between the lunar nodal cycle of 18.6 years and the 2-year synodic period of eclipse seasons. By moving markers around the 50, 6 holes at specific rates corresponding to the movements of the sun, moon, and the 2 nodes where the lunar orbit crosses the ecliptic, you could predict with startling accuracy when eclipses would occur, not by understanding the orbital mechanics, not by doing mathematics in the modern sense, simply by moving stones around holes at the right pace, reading the positions, and knowing what the patterns meant. The leading archaeologist of the time, Richard Atkinson, responded to Hawkins's theory with a paper whose title, Moonshine on Stonehenge, tells you everything about the institutional reception the idea received. Atkinson called the builders of Stonehenge howling barbarians who could not possibly have possessed the intellectual capacity for such systematic astronomical thought. He was wrong about that. He later admitted he was wrong about that, but the damage was done, and the conservatism of the archaeological establishment meant that even as subsequent astronomers, most notably the astrophysicist Fred Hoyle, refined and improved Hawkins's eclipse prediction model, the idea that Stonehenge was a functional astronomical computer remained on the fringes of academic acceptability for the next 60 years. Fred Hoyle's refinement of the model is worth dwelling on because it is one of the keys to what the Grok AI analysis confirmed and extended. Hoyle showed that with 4 markers, one for the sun, one for the moon, and 2 for the nodes, moved around the 56 Aubrey holes according to simple rules tied to their actual orbital periods, you could predict lunar and solar eclipses with an accuracy of 99.8%. The system required no calculation in the symbolic sense. It required only memory, the knowledge of how to move the markers passed from keeper to keeper across generations. But the system only works because 56 is the specific number, not 54, not 58. 56 is the number that makes the orbital mathematics of the sun. Moon relationship close enough to an integer relationship to be tracked on a counting device. The people who decided to dig 56 holes, not some other number, knew that. They knew it well enough to dig it into the earth permanently before the first stone was ever raised. This is the context into which Grok AI entered with the full data set in 2026. And the first thing the AI found was something that confirmed and quantified what Hawkins and Hoyle had argued, but that the field had never formally accepted. The 56 Aubrey holes are not approximately evenly spaced. They are not close to evenly spaced. They are evenly spaced to a precision that T, when measured against the full circumference of the circle they describe, shows a variation between adjacent holes of less than 0.5%. Human beings without surveying instruments laying out a circle over 100 meters in diameter and marking 56 points around its perimeter. I produced a geometric result that a modern engineer with modern tools would be proud of. The AI's measurement of that precision was not a qualitative judgment. It was a number, and the number was not consistent with an approximation. It was consistent with a system. The second finding was more unexpected and came from the AI's analysis of the spatial relationship between Stonehenge and the wider landscape that surrounds it. For decades, archaeologists working the Stonehenge landscape had known that the monument was not isolated. It was surrounded by hundreds of other prehistoric features, barrows, processional avenues, earthworks, standing stones, and smaller circles scattered across the Salisbury Plain. The Stonehenge Hidden Landscapes project, using ground-penetrating radar and magnetometry, had, by 2025, identified hundreds of previously unknown subsurface features across nearly 3,000 acres of the surrounding landscape, including a circle of more than 20 enormous shafts, each over 10 meters in diameter and 5 meters deep, forming a ring more than 2 kilometers across around the nearby settlement of Durrington Walls. The individual features had been cataloged, but no human analytical team had ever been able to process the entire spatial dataset simultaneously and look for patterning at the landscape scale. The AI could. And what it found in that landscape data was that Stonehenge sits not at a random point on the Salisbury Plain, but at the geometric center of a network of features whose spatial relationships encode the same astronomical information that is built into the monument itself. The avenues, the barrows, the shaft circles, they are not clustered randomly around Stonehenge. They are arranged in a pattern that extends the monument's astronomical geometry outward into the landscape, effectively turning the entire Salisbury Plain into a single integrated astronomical instrument far larger than the stone circle at its center. The third finding brought the question of the builders into sharper focus than it had ever been before. In January of 2026, researchers from Curtin University published a study in the journal Communications, Earth and Environment that delivered what they described as the strongest scientific evidence yet that Stonehenge's bluestones were transported to the site by people rather than by glaciers. Using advanced mineral fingerprinting, analyzing the microscopic mineral grains preserved in river sediments near Stonehenge and tracing their provenance, the researchers found no geological signature of glacial transport through the region. If glaciers had carried the bluestones from Wales or Scotland to Salisbury Plain, they would have left a characteristic mineral trace in the sediments of the rivers that drain the area. That trace does not exist, which means the stones came by human hands, all of them. The 4-ton bluestones from the Preseli Hills in Wales, 225 kilometers away. The 6-ton altar stone from northern Scotland, at least 500 kilometers away. Across hills, rivers, coastlines, and open water. Neolithic people without wheels, without draft animals suited for heavy hauling, without metal tools, without writing, moved these stones to a specific point on a specific plain in southern England because that specific point was where the monument had to be. The question the Grok AI analysis is most useful for answering is not whether they did it, but what it implies about them that they did. Because when you feed all of the data into a system that can read it without prejudice, the astronomical precision of the monument, the geometric precision of the Aubrey holes, the coordinated landscape scale planning revealed by the geophysical surveys, the logistical scale of the stone transport, the 15th century construction timeline showing consistent adherence to an original design concept. What comes back is a picture of a civilization whose intellectual and organizational capabilities we have systematically underestimated. Not because the evidence was not there, the evidence was always there, but because no human analyst had ever been able to hold all of it simultaneously in a single field of view and let it speak as a whole. What it speaks as a whole is this. The builders of Stonehenge understood the sky in a way that most modern people do not. They understood the 18.6-year lunar nodal cycle, a cycle so long that no individual human being lives through it 3 times, which means that the knowledge of it could only have been preserved and transmitted through a social structure specifically organized around that transmission. They understood the relationship between that cycle and the occurrence of eclipses well enough to encode a predictive system into the geometry of a monument. They understood how to survey a circle over 100 meters in diameter to a precision of less than 0.5% without instruments that we know they had. They understood how to coordinate the transport of specific stones from specific geological sources across hundreds of kilometers of challenging terrain. And they did all of this not for 1 generation or 2, but across 15 centuries, with each generation's work building coherently on the generation before it, following a plan that was never written down and never needed to be. Because the monument itself was the plan, and the plan was in the stone. The AI's finding about the mathematical knowledge encoded in Stonehenge was the one that produced the sharpest intake of breath among researchers when it was circulated. Because the numbers embedded in the monument's geometry are not simple. The relationship between 56 and the lunar nodal cycle is not an obvious relationship. It requires knowing the nodal cycle's length to a precision of at least 1 decimal place, knowing the synodic period of eclipsed seasons, knowing the relationship between these 2 cycles, and recognizing that 56 is the smallest integer that makes a useful approximate ratio between them. That is not observational astronomy. That is mathematical astronomy. The kind of mathematical reasoning that mainstream history attributes to the Babylonians around 700 BC, 2,000 years after Stonehenge's Aubrey holes were dug. And the AI found not one such mathematical relationship embedded in Stonehenge's structure, but several, layered across different phases of the monument's construction, as if each phase was adding a new register to an instrument being refined over time. There's a detail from the 2025 archaeological research that the AI analysis incorporated and that deserves to be heard on its own terms. A study published in the Journal of Archaeological Science used a machine learning algorithm to identify previously undetected carvings on the surface of Stonehenge's stones. The algorithm, trained on existing known carvings, was able to identify 4 new axe head carvings on Stone 53 and flag 9 previously misidentified ones, working from laser scan data with 90.7% accuracy. Separately, a study addressed the problem of lichen covering 23% of the monument's surfaces and used AI-assisted simulation to virtually remove the lichen and predict what might be hidden beneath it. These are small findings in the context of the larger picture, but they are symptoms of the same shift, the application of machine analysis to a problem that human observation working alone has reached the limit of its ability to advance. And the major lunar standstill, documented by Bournemouth University researchers in 2024 and 2025, adds a final dimension that the Grok AI analysis treated as significant. The major lunar standstill is an astronomical event that occurs every 18.6 years, the same cycle embedded in Stonehenge's Aubrey hole count. At standstill, the moon rises and sets at its most extreme positions on the horizon, positions that correspond precisely to sight lines defined by Stonehenge's station stones. The 2024-2025 standstill was captured with modern equipment, and the alignment was confirmed to hold. The moon, at the extreme of its cycle, rises exactly where the builders of Stonehenge built their stones to mark it rising, after 5,000 years. Through 5,000 years of atmospheric change, geological settling, and the slow wobble of the planet's axis, the alignment holds. What Grok AI brought to Stonehenge in 2026 was not a single dramatic discovery that overturned everything that came before. It was something more precise and ultimately more significant than that. It was the ability to read the monument as a whole, to take every piece of data that had been gathered in isolation by individual research teams working on individual problems, and see it as a unified system. And what that unified reading showed is that Stonehenge was not a burial ground, not a temple, not a solstice celebration site, not an eclipse predictor in isolation. It was all of those things simultaneously integrated into a single design that encoded the structure of the sky into the structure of the land, that turned the relationships between celestial bodies into relationships between stones, that made the abstract cycles of astronomical time physically visible and physically navigable by any person who knew how to read what they were standing inside. The people who built it were not primitive. They were not simple. They were not limited by the absence of writing or metal or the other material markers that we use to define sophistication. They were sophisticated in the way that the monument itself is sophisticated, in a way that takes the long view, that thinks in centuries rather than years, that values the transmission of knowledge above the accumulation of wealth, that builds not for individual glory but for something that has to last longer than any individual life, longer than any dynasty, longer than any institution that the civilization itself would produce. Stonehenge is still standing. The civilization that built it is not. And yet the knowledge encoded in the stone, the record of what those people understood about the sky and chose to make permanent, is still readable by anyone who knows how to look. The AI knows how to look. It does not romanticize what it sees. It does not project meaning onto numbers that do not carry it. It simply measures, compares, correlates, and reports. And what it reported from the Stonehenge dataset in 2026 was this. Every major feature of the monument, when analyzed simultaneously and without prejudice, converges on a single coherent purpose. Not a guessed purpose. Not a theorized purpose. A purpose that is written in the relationships between the numbers, between the stones, between the monument and the landscape around it, between the structure and the sky above it. Stonehenge was built to track time on the grandest scale that a human civilization embedded in the rhythms of the natural world would have needed to track it. The time of the solstice, the time of the lunar extreme, the time of the eclipse, the time of the planting, the time of the harvest, the time of the tide. All of it, together, encoded in stone on a plain in southern England by people who understood something fundamental, that the sky is a clock, and that a civilization that can read the clock is a civilization that can survive. The monument has been standing for 5,000 years. The clock is still running. And for the first time in that 5,000 years, something read it completely.